Good day. Welcome to another section of Farmer's tutorial. In our previous video, we looked at probability theory. Today, we will be looking at mutually exclusive and independent events. When we say two events are mutually exclusive, basically it means that two or more events cannot occur together, or the occurrence of one event prevents the other from happening. So assuming you have this particular coin, and you have a head and a tail. When events are said to be mutually exclusive, basically it means that these two events, that's events one and event two, that's the head and the tail, it cannot occur together in a single experiment. So imagine, or if you throw this particular coin, you cannot get a head and a tail at the same time. It's either you get a head or a tail. So mutually exclusive events is basically events that cannot occur together or that cannot occur at the same time in a single experiment. But assuming we have two coins, so this assuming we have coin 1 and coin 2, we have coin 1 and coin 2. This cannot be a mutually exclusive event, but this can be mutually inclusive event because when you toss or when you flip this particular coin, that's coin 1, you can get a head as a favorable outcome. And when you toss, when you flip the coin 2, you can also get a head. But in mutually exclusive events, that's one experiment. In a single experiment, you cannot get a head and a tail at the same time. That's simultaneously. It's either you get a head or a tail. But in the case of mutually inclusive, when you toss this particular two coins, assuming you toss the two coins, that's the two coins simultaneously, you can get a head in the coin 1 and a head in the coin 2. But in the case of mutually exclusive, it doesn't happen that way. Under what circumstance do one know that a particular question is under mutually exclusive event, or this particular question or statement is under mutually exclusive? You will get to know that a question fall under mutually exclusive events when you hear a phrase like or either. When you hear these two phrases, when you hear or, either, and union, that's union. When you hear this particular three phrases, you have to know that that particular question is under mutually exclusive events. So events, assuming we have events A and events B. So the probability of event A or the probability of event B is equal to the probability of event A plus the probability of event B. So if you have a question under mutually exclusive event, this is how you solve it. It is probability of event A or probability of what? Event B. So when you are solving, this is how you solve it. You solve the probability of each or every event. So in this case, we have two events, that's event A and event B. And if you are to ask or if you are solving, you have to find the probability of event A. After that, you add it to the probability of what? Of event B. But in the case of mutually exclusive, the probability of A and probability of B is equal to probability of A or probability of A intersection B is equal to what? 0. This means that the two events cannot occur together. In the case of mutually exclusive event, two events cannot occur together. So probability of event A and in probability, or means union, and means intersection. So and here indicates multiplication, whilst the or here indicates addition. So in every probability question that you see, if you see and, it means multiplication. If you see plus or addition. So if you see or, it means addition. So probability of A and B cannot occur together. So as a matter of fact, it becomes what? 0. And when you are doing probability, the limit of probability or behind probability, the limit is 0 less than or equal to 1. Sorry. In probability, if you are certain about an event, let's say you are certain that an event will occur, its probability is what? Is 1. But if you are not certain about a particular event, the probability of that event is what? Is 0. So that's the limit of probability. Probability ranges between 1 and 0. Probability ranges between 1 and 0. So let's look at example under mutually exclusive events. Example under mutually exclusive events. So I have a question here that I want us to solve. So a bag contains 5 bags of red. So we have a bag. So assuming this is our bag, and it says that this particular bag contains 5 balls of red. So we have 5 balls of red and also 4 green balls, 4 green balls and 6 white balls. So we are made to understand that this particular bag contains 5. Sorry, it contains 5 red balls, 4 green balls and 6 white balls. So we are asked to calculate a probability that a green ball or a white ball is picked. We are asked to calculate that the probability that a green or white ball is picked. So the first one says that what is the probability that you pick a green ball, that's green, or a white ball? So the green here represents the green ball while the white represents the white ball. What is the probability that you pick a green ball or a white ball? Before you solve this particular question, this is a typical exclusive, mutually exclusive event. This particular example is under mutually exclusive event. So if you want to know the probability that when you put your hand in this particular bag, you pick either a green ball or a white ball. Before you solve, you have to know the total number of balls in this particular bag by adding the red ball to the green ball and to the white ball. So the total number of balls in this particular bag is 15. So our sample space is equal to what? Is 15. That's the total number of balls in this particular bag is 15. So if you want to know the probability that you pick either a green ball or a white ball, you first have to find the probability of picking a green ball. After that, you also find the probability of you picking a white ball. Then you add the probability of you picking a green ball or to the white ball. So let's first find the probability of we picking a green ball. So probability of picking a green ball is giving us, we know that green ball is our favorable outcome. We are interested in picking a green ball. So in our previous video, we learned that probability is equal to number of favorable outcome over total possible outcome. So in this case, our favorable outcome, which is the probability of we picking the green ball, is the green ball here, which is what? 4. So the probability of we picking the green ball here becomes what? The number of favorable outcome, which is what? 4, divided by the total number of possible outcome. In the bag, we have 15 balls in this particular bag. So it becomes the total number of what? Possible outcome. That's the total number contained in this particular bag. So it becomes our total number of possible outcome, which is what? Which is 15. So the probability of we picking a green ball, if we put our hand in this particular bag, is what? Is 4 out of 15. After finding the probability of we picking a green ball, we have to also find the probability of what? We picking a white ball if we put our hand in this particular bag. So probability of picking a white ball is equal to the number of favorable outcomes. In this case, our favorable outcome is not red, it's not green, but rather it's white, divided by the total number of possible outcomes, which is what? Which is 15. So the probability equals 6 out of 15. 6 out of 15. So we find the probability of independent events. That's the probability of we picking the green ball and the probability of what? We picking the white ball. Now we are to find the probability that we pick either a green ball or a white ball. I hope it's understood. We are to find the probability of we picking a green ball or a white ball if we put our hand in this particular bag. But you can't find it if you don't know the probability of what? Picking a green ball or the probability of what? You picking what? A white ball. So the probability of we picking a green ball, which is represented as J, union probability of we picking a white ball, or you can write it this way: probability of you picking a green ball or probability of you picking a white ball is giving us the individual probability, which is the probability of you picking a green ball plus the probability of you picking a white ball. So this is the formula for mutually exclusive events. If you have to pick what, a green ball or a white ball in this particular bag, so we know that the probability of we picking, if we put our hand in this particular bag, we are going to get what? We are going to get 4 out of 15 plus the probability of we picking a white ball, which is also 6 out of what? Out of 15. So now we do our calculation. It gives us what? 2 out of 3. 2 out of 3 or 0.67. 0.67. So the probability, if we put our hand in this particular bag, its probability or the probability of we picking either a green ball or a white ball is 2 out of 3. Is 2 out of 3 or 0.67. 0.67. I hope it's understood. And the second one also says that we should find the probability of we picking a white ball or a red ball. So let me clean this one so that we find the probability of we picking a white ball or a red ball. We picking a white ball or a red ball. Okay. So our sample space still remains 15. And the probability of we picking a white ball or a red ball. Okay. Probability of we picking. Previously, we know that the probability of we picking a white ball, which is PW, is equal to 6 out of 15. Now, we don't know the probability of we picking a white ball, a red ball. So we have to find its probability. We know that there is a total number of 5 red balls in the bag, and the total outcome, that's the total number of balls, is also equal to 15. If you want to know the probability of you picking a red ball, if you put your hand in this particular bag, it is the number of favorable outcome, which is the red balls, that's the 5, out of the total number of balls in the bag, which is 15. So we are going to get 5 out of 15, which is also equal to 1 out of 3. Which is also equal to 1 out of 3. So after getting it, you do your addition. So we have probability of you picking the white ball as 6 out of 15. Probability of you picking a red ball to be 1 out of what? Out of 3. So if you put your hand in this particular bag, the probability of you picking a white ball or red ball is giving us probability of white ball plus the probability of red ball. And you know the probability of white ball to be 6 out of 15 plus the probability of you picking a red ball, which is 1 out of 3. So 6 out of 15 plus 1 out of 3 is giving us 11 out of 15. So if we put our hand in this particular bag, the probability of you picking a white ball or a red ball is giving us, or it is 0.733 or 11 out of 15. If we put our hand in this particular bag. Earlier, we find the probability of you picking a green ball or a white ball. Now, we are finding the probability of you picking a white ball or a red ball, which gave us what? 11 out of 15. I have another example that I want us to solve. So, we have on board of 500 workers at a company, 250 are junior workers, 210 are line workers, and the rest are senior workers. If a worker is selected at random, what is the probability that A junior worker or a senior worker is selected, B, a line worker or a senior worker is selected? So if we have an example, or if you have a question under this particular topic, which is the mutually exclusive event, or any other probability subtopic, try to analyze and understand the question before you start. So let's analyze the question together. So in a company, we have 500 workers. So it becomes our sample space. That's the total number of workers, which is 500. And out of these 500 workers, we are made known that 250 of the 500 are junior workers. So we have junior workers. So let's J represent our junior workers, which is 250. And 210 of the 500 are line workers. So let L represents line workers. So we have 210. And it says that the rest are senior workers. So you just add this two, you subtract it from the 500 to get your senior workers. If you add these two and you subtract from your 500, this is the sample space, you are going to have switches as senior workers to be what? To be 40, because this will give you 460. 460 minus 500 will give you what? Will give you 40. So now we've established our values. This is the values that you are going to solve for the probabilities. Now let's go to the first one. It says that if a worker is selected as random from the company, what is the probability that we pick a junior worker or a senior worker? So in this case, it's either you pick a junior worker or a senior worker. You cannot pick the two at the same time because they are mutually exclusive. Remember we said that mutually exclusive events are events that cannot occur simultaneously, or the occurrence of one event prevents the other event from occurring or from happening. So in this case, you cannot pick or you cannot select a junior worker and at the same time select what? A senior worker. That's under mutually exclusive event. So let's establish a probability for junior worker and what? And senior worker. So if you want to know the probability of you picking a junior worker, the probability of you picking a junior worker is the favorable outcome, that's the number of favorable outcome, which is what? 250 for junior workers, over the total number of outcome, which is what? Which is 500. So we have 250 all over 500, which gives us what? 1 out of what? Out of 2, which is also 0.5. Probability of picking a line worker. Probability of picking a line worker is 210, which is the number of favorable outcome out of the total number of what? Possible outcome of what? 500 workers. So we have our 210 out of 500. 210 out of 500 is also what? 21 out of 50. So we have 21 out of 50. Now let's move to the probability of you picking a senior worker, which is 40 out of 500. So we have probability of you picking a senior worker is what? 40 out of 500. Also gives us what? 2 out of 25. So we've established the probability of you picking a junior worker and a probability of you picking a line worker, and the last one is the probability of you picking a senior worker. So now let's go to the question. The first one, it says that if a worker is selected as random from the 500 workers, what is the probability that we picking a junior worker and the probability of you picking a junior worker or a senior worker? So we have a probability of we picking a junior worker or probability of we picking a senior worker. And we know that in probability, all means what? All means addition, and end means multiplication. So the probability of you picking a junior worker or senior worker is probably giving us the probability of we picking a junior worker or the probability of we picking a senior worker. And we know the probability of junior worker and senior worker. So we have the probability of junior worker, which is 1 out of 2, plus the probability of we picking a senior worker, which is also, senior worker is somewhere here, which is also 2 out of what? Out of 25. So the probability of you picking a senior worker is 2 out of what? Out of 25. So 1 out of 2, 1 out of 2 plus the probability of you picking a senior worker, which is 1 out of 25, is equal to 29 out of what? Out of 50. So if we go to the company right now, the probability of we selecting a senior worker randomly, the probability of you picking a senior worker or a senior worker is what? Is 29 out of what? 50, which is also equal to 0.58. Let's move to the B. B says that if we select as random, what is the probability of you picking a line worker or a senior worker? The probability of you picking a line worker is what? So we have our formula, probability of you picking a line worker, which is represented as what? As L, or a senior worker as what? As S. So we have the probability of you picking a line worker plus the probability of you picking a senior worker, and it's giving us line worker, which is 21 out of 50. So we have 21 out of 50. 21 out of 50 plus the probability of you picking a senior worker, which is also 2 out of what? out of 25, 2 out of 25. So we have 21 out of 50, 21 out of 50 plus 2 out of 25, which is equal to what? 1 over 2 or 0.5. So you see that the question is not difficult, it's very simple. So the probability of we picking as randomly from a company, if we are to pick a line wrecker or a senior wrecker, is what? Is 1 out of 2. And the probability of we picking a junior wrecker or a senior wrecker is what? Is 29 out of 50, which is the same as 0.58 or 58%. This brings us to the end of this particular video, that's mutually exclusive events. In our next video, we are going to talk about general addition rule and independent events. Thank you for watching.